So welcome to this video, which is about congestion control. The purpose of the video is to give you an understanding of basic mechanisms to handle congestion control at the network layer, and this includes choke packets and explicit congestion notification. So congestion control appears if the actual traffic exceeds the capacity in a larger or smaller part of the network. So the problem we will have is, for example, if more packets are being sent than the network is able to handle, then we kind of need to handle this congestion. So looking at the figure here, in the perfect situation, then the number of packets sent, if we go all the way up to the maximum limit, would be equal to the number of packets delivered. The problem with congestion is that even if you haven't reached your capacity and you start to experience congestion, then the number of packets sent will actually decrease, and you will be far away from your capacity. And of course we don't want that situation, because it gives the users a bad experience and it's an inefficient way of using the network. So what we want is what is here called desirable. So to try to get as close to the maximum carry capacity as possible. When preventing congestion, we can say that, of course, designing networks with sufficient capacity and avoiding bottlenecks is one way of doing it. But the problem is that if one bottleneck disappears, then often a new one occurs, and it can also be really expensive to design networks which can handle all the data that it ultimately can be experiencing. In this case, it's generally desired that as many packets as possible come through the network so that the throughput is maximized. But there is also a fairness game to play here. So in the figure you see here, you see that assume that the bottleneck is between X and X mark, which is on the other side. So you have a communication between X and X mark. And the problem is, if you really wanted to maximize the throughput in this network, then when A and A mark and B mark and C mark are communicating with each other, then every time you send a packet from X to X mark, then you decrease the capacity of A mark, B mark, C mark, etc. So if I just wanted to maximize the number here, I could send 100 packets per second between A and A star, 100 between B and B mark, and 100 between C and C mark. That would be 300. But every time I add in a packet between X and X mark, I reduce each of the other ones by 1. So in this case, if I only maximize throughput, I will not set anything between X and X mark. But of course, you can discuss, is this fair and is this desirable? Some general comments about preventing congestion is that, first of all, you need to monitor the system in order to know if some kind of reaction is necessary. Then when you do this monitoring and there is a need for it, then you need to send this relevant information to the relevant entities so that they can, and that is the next step, act accordingly to this information. Watch out here, because it's easy to make the troubles larger. So we really want to avoid oscillations. We want to avoid stop and go, and we want to avoid increasing the traffic too much. So whatever mechanisms we do to handle congestion control should not by itself take up too much capacity of the network. It's important also to mention that congestion control is affected by more layers, and that you do different things in different layers. And I'll just leave the figure here for you to study it, and then I will continue with what we are doing in the network layer. So examples of congestion handling mechanisms. Choke packets is one example. So assume that we're sending data from A to C, which passes through an intermediate node B, which is experiencing congestion. Then what it can do is that it can send a packet back from B to A, asking to slow down. So the man in the middle, or the node in the middle, is then asking, please slow down. The challenge with this is, of course, that you actually, to deal with too much traffic, you induce even more traffic in the network. Then you have another scheme which doesn't require any new traffic to be added, and that is called explicit congestion notification. So here if a packet is experiencing congestion along the way, we mark it somewhere in the header. And when it is received by the receiver, in this case it would be C, next time C is sending a packet to A, could be a reply packet or an acknowledgement packet, then we set this notification in this packet as well. So what it means is that eventually C will be notified, or eventually A will be notified that it should slow down. The problem with doing it in this way is that it takes more time before it reaches the source, because first it has to get from B to A, and then it has to first it has to go from B to C, and then it has to get back from C to A. This reaction time can be compensated, for example, by using what is called hop-by-hop back pressure, meaning that as soon as an intermediate node sees that a node has set this notification, then it will slow down to speed. And also when the reply packet is then coming up, it will also slow down to speed along the way. The problem with this back pressure is that when you slow down to speed in the intermediate nodes before it is slowed down in the center node, then the traffic might be accumulating for some time. But on the other hand, it might be nice to take off the pressure where it's absolutely most needed. So this is the end of this video. Please let me know if you have any questions or comments. Thanks.